When we're talking about real numbers, there are certain properties that we need to be familiar with because they apply, especially in algebra. The first is the commutative property of addition, which means that x plus 2 is the same as 2 plus x. In other words, we can turn it around and it hasn't changed its value at all. Multiplication works the same way. We have a commutative property there. X times 2 would be the same as 2 times x. And then we have an associative property of addition, which means that we can group numbers that we're adding. If the operation is just addition, then we can add them in any order we want to, really. And multiplication, if it's all multiplication, we can multiply them in whatever order we want to. Then the last one is the distributive property of multiplication, which means that anything outside parentheses would be multiplied times each term inside parentheses. And terms, remember, are separated by either addition or subtraction. Let's look at these and see what they mean to us as far as doing algebra. In example 1, we have r plus 3 plus 11, and the r and 3 are grouped, but they're not like terms. They can't be combined. So we could regroup them. We could make this r plus, and then we could say 3 plus 11. In other words, we can still change that to add the 3 and 11. Our answer would be r plus 14. The terms are not alike. That's as simplified as that expression will get. Example 2, we have a 2 outside parentheses, which means multiply. Well, when you're multiplying a 2 times this term inside, you multiply the coefficient of the variable term. The coefficient is the number, the 42. So I would say 2 times 42, that would give me 84. It's already multiplied times x, so I say it is 84x. Same thing if I multiply a fraction times a whole number. Now this one doesn't look really great on your paper. I'm going to rewrite it. I'm going to say 1/8 times, because that's the same as the parentheses there, 8z, and I'm going to write the 8z as a fraction. In other words, I'm just going to put 8z over 1. I don't really multiply whole numbers and fractions. I turn the whole number into a fraction by putting a denominator of 1. Now, I could cross-reduce the two 8's here, or I could go ahead and say 8z times 1 is 8z over 8, and then I could reduce the 8's. They divide into each other, and I end up with just plain 1z over 1, which is just z. For example 4, let's distribute this multiplication. We're going to multiply the 7 times each term inside parentheses. I'm going to say 7 times a would give me 7a, and then I'm going to say 7 times b is going to give me 7b. For number 5, I'm going to do sort of the same thing. I'm going to say 5 times 7 would be 35. And then 5 times this positive 8y would give me a positive 40y. Now remember, the sign that's in front of the term stays with that term. So I multiplied a 5 times a positive 8y. It became a positive 40y, and the plus, the positive sign, became the addition operation to separate the terms. For example 6 is a little confusing to us because it's a fraction, but it works the same way. 1/2 times 6x, I'll just write it down if I get confused. 1/2 times 6x, and that's a whole number, I'll put it over 1, plus 1/2 times 8 over 1. That's the second term I'm multiplying by. Now these are pretty easy. I do the multiplication, but before I do it, I cross-reduce. 2 will go into both 2, and 6x becomes 3x, right? So 1 times 3x is 3x plus, and I can divide or reduce by 2 and 8, and 1 times 4 is 4, and all the denominators, C, are 1s. So these would be 2 whole numbers because the denominator 1 does not have to be written. Now look, can I combine those 2 terms? Well, I can't because they're not like terms. Remember, for terms to be alike, they have to have the same variable. In this one, I have a variable of x, and I have no variable at all. So they're unlike terms. They cannot be simplified or combined. Example 7, let's distribute multiplication first. 3 times 2r would give me 6r. 3 times 5 would give me a positive 5, or 15. And then let's just bring down the negative 7. Now look, can I combine like terms? Well, I have 2 terms here that are alike. They're both just numbers. 6r has nothing matching, so it's 6r. 15 minus 7 is a positive 8, and that becomes the operation separating the terms. Example 8, negative 4 times 4x. Well, negative times a positive, negative 16x. Negative 4 times positive 5, a negative again, negative 20. and then I bring down my negative 5 or my minus 5. What terms can I combine? Well, the negative 20 and the negative 5 are like terms. They have the same variable. They don't have a variable, right? Negative 20 minus 5, both negatives, add them together, keep the sign. Oops, forgot to write 16x. There it is. 16x minus 25 is the answer. Now, example 9 is a little different. I've already combined these terms. They've distributed multiplication. I want to know, can we go backwards? In other words, what do you see that is a common factor of both 9y and 9b? If I were to say 9 can come out of both of those, I would have something plus something left inside parentheses. Well, what do I multiply 9 by to get 9a? Well, it would be a. And what do I multiply 9 by to get 9b? Well, it would be b. This is the part where you're trying to come to in algebra so that we can factor. We have to be able to go forward and backwards with each of these processes of distributing multiplication.